Alright, I'm gonna post some videos on perimeter and area, how to find the perimeter area using the coordinate plane here. So these two examples are probably the same ones in the video, maybe or maybe not, but I'm gonna do a number of pages. Some of them might be in the video from the county or there they could not be, but it won't hurt to reinforce something you've already seen on the county videos. So what do we need to know in order to determine the perimeter shape? We need to know the lengths of the sides. And how can we determine the lengths of the sides? We could usually use the distance formula, or we can just count. So if it's horizontal or vertical, excuse me, we can just count the length of the sides. For example, from A to B here is 3 units, and then from B to C is 7 units, but I cannot count the number of units on a diagonal. I have no idea of how long this is right here. So on this triangle here, I can use, because it's a right triangle, I can use Pythagoras. 3 squared plus 7 squared equals c squared. So 9 plus 49 equals c squared. C squared is 58, and then take the square root, and c is the square root of 58. Or like in the video, the first video they show you is you can use the distance formula. So here's a 0.52 and here's a point -1, -2, -1. So what you do is subtract the x values, -2 minus 5, and square that, and then subtract the y values, -1 minus 2, and square it is so -7 squared is 49, and then -3 squared is 9. So you get the square root of 58. Either way, using Pythagoras or the distance formula. So distance formula is actually using Pythagoras. It's actually using, if you see this right here, it's actually using 7 squared plus 3 squared here. It's actually finding these distances here, and then square those. Sum of the square root is this side right here. So this one is much easier, this rectangle, because I can just count. So this length is 3, this length is 5. Since it's a rectangle, opposite sides are equal, 3 and 3, and these opposite sides are equal, 5 and 5. So the perimeter, just adding it up, 3 plus 5 and 3 plus 5 is 16. And then the area of a rectangle is base times height, 3 times 5, or length times width, is 15. Over here, the perimeter, 3 plus 7 plus the square root of 58 is 10 plus the square root of 58. So on your check for understanding, they want you to get the decimal approximation for this. So I could just go to my Desmos calculator, and the way you do that is just type in Desmos in your search bar, and then go to graphing calculator. And then so back here, if I wanted to get the decimal approximation for this perimeter, is 10 plus the square root of 58. So I want to go to here. Oh, this is hiding the keyboard. You want to go to the keyboard, 10, and then plus square root 58, and it's approximately 17.6. So back here, I could actually write that here, that my perimeter is approximately 17.6. Okay. And then the area of this triangle is 1/2 the base times the height. So I could either use either of these for base and height. So 1/2 of 7 times 3, 1/2 of 21 would be 10.5. Okay, so I tend not to use the distance formula because, like in the video, it's just something else to remember. If you just use the alternative method that they showed, is using rectangles, and in the videos I'll show you what I mean with that. So, so this second slide says, what does it mean to find the area? So you find the amount of square units enclosed by a figure if you want to find the area. And what's one way to find the area is to count the squares. Well, you'll notice that these are the same two things here. Easy enough to count the squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But over here, you can count the full squares here and try to get an estimate of the perimeter. But the only full squares I see are 1, 2, 3, 4. That's almost a full square. And then 5, 6. So there's 6 full squares and then partial squares here. So I know the area is bigger than 6. Happens to be 17.6. But then you'd have to count each one of these. It's very difficult to count what partial square is this. I don't know. So much easier to find the base times the height divided by 2, and that gives me 10.5. So I was looking at the wrong number here. So if I wanted to find the area, it's 10.5. I could count 1, 2, 3, 4, 5, 6 full squares. So I know it's more than 6. It's actually 10.5. All right, this is the same as in the video, but using the alternative method here, I just drew a rectangle. And this happens to have one horizontal side here, so that side becomes part of the rectangle. And then I get the dimensions. So from -3 to +3, that's 6 units there. And so this side has to be the same. And then from -5 to +3, that's 8. And since this whole side is 10, this has to be 2, and I can count that. There's 2 there. So now I have actually 3 triangles here. So if I want to find the perimeter, I do Pythagoras here. 6 squared plus 8 squared is, so in other words, how did I find this 10 here? I did 6 squared plus 8 squared is equal to c squared, because I didn't know what that was. I knew what these two sides were before I found this. Then I have 36 plus 64 is c squared, and 100 is equal to c squared. So c is 10. Some of you might recognize that this is the same as like a 3, 4, 5 triangle. So just doubling everything. Twice 3 is 6, twice 4 is 8, twice 5 is 10. So this is in the form of a 3, 4, 5 triangle. So this side is 10. And how did I get this square root of 40? I have 2 squared plus 6 squared is equal to c squared, and then 4 plus 36 is c squared. So c is square root of 40. All right, and then this side you just can count. So from -5 to +5, that's 10 units. So the perimeter, just adding up the sides, 10 plus the square root of 40. You have 20 plus the square root of 40. You could put that on the calculator. So how did I find the perimeter? I used right triangles in Pythagoras to find 2 sides of the original triangle. The side that is 10 right here is, I just counted those, and then I add them up. So then the strategy for determine the area. So they said show two strategies. Well, one, you could use the distance formula and find each one of these distances here. And then that's to find the perimeter. And then the area would just be this base, and then you have to find this height from here to B. So you want the perpendicular height, which is this right here, 6. So I can use the big rectangle here. It's a 10 by 6, so 60, and then subtract each of these areas. So it's 1/2 8 times 6, and 1/2 of 2 times 6 is the area of these two triangles right here. So 24 plus 6 is 30. So I take the large rectangle, 60 minus the two, I can call them the two purple triangles here, and then I get 30 square units. So the other way would just be, say, this base is 10, this height is 6, multiply those two together, 10 times 6, and divide by 2, and you would get 30 that way also. Here's page 23. I think this is the same triangle that was in the Montgomery County video, but using the rectangle method here. So I just draw a large rectangle around the triangle so it's enclosed in the rectangle, and then just count the sides here. 11 from -7 to +4 is 11, from 46 is 2, and then from -7 to +1, that's 8, and this whole side goes from -7 to +6, so 13, and then from +1 to -4 is 5, from -4 to -7 is 3. So that's all there's 3 what I'll call purple triangles here now. And the way I found each of these sides, then I did 13 squared plus 5 squared, so 13 squared plus 5 squared equals c squared. So 169 plus 25 equals c squared. So 194 equals c squared, and then c equals square root of 194. So one nice thing about using the rectangle method here is you can find both the perimeter and area rather easily once you find the legs of the right triangle. You can find the area easily. The perimeter you can find by using Pythagoras. So this other triangle, I had 8 squared plus 2 squared is equal to c squared. So 64 plus 4 is c squared, and then c is the square root of 68. That's this side here. And then the final side, I'll do it up here. 11 squared plus 3 squared equals c squared. So 121 plus 9 is c squared. And then 130 c squared, c is square root of 130. So the perimeter, just add these up. And on the check for understanding, like I said before, you can use the Desmos calculator to get the approximation for this. This is the exact answer right here. So to find the perimeter, I found the hypotenuse of each of these purple triangles here, and then add them together. And then the area, I took this large rectangle, it's 13 by 8. So 13 by 8 is 104. And then subtracted off the 3 triangles there. And I have 104 minus 8, and this adds up to 49. So subtract those, and I get 47. So what did I do there to get the area? So I subtract the area of the triangles. I should say triangles here. Let me fix that. Subtract the area of the triangles from the area of the rectangle. And that's the method I prefer using because that way, excuse me, you probably, as long as you count these correctly, then you'll avoid errors with subtracting negatives and doing the square root of something squared. So remember, when you're subtracting, you put everything in parentheses. So when you square a negative number, you get a positive number. So see students doing that incorrectly and then get the wrong answer for the lengths of the sides using the distance formula. So I think it's better to use the second method they show you, is just to enclose everything in a rectangle. And then find the sides, find these sides by Pythagoras, and then find the area by taking the area of the rectangle and then subtract off these triangles, and you end up with this area right here. Right. So one more page, and then I'll do a second video instead of make one really long video. All right, so find the area of the polygons and choose one polygon to determine its perimeter. So once again, I enclose this parallelogram in a large rectangle here, and then find all the sides here. And so this is the one I chose to do the perimeter. So the way I got these sides is use Pythagoras, and then we'll just add those together. So both of these are square root of 41. Get out of there. Both these sides are square root of 41. These two sides square root of 68. Add them together. The perimeter is 2 squared 41 plus 2 squared of 68. And then the area, this whole side is 8, and this whole side is 13. So 8 times 13 is 104. And then I subtracted the 4 triangles there. 2 of them were 4 by 5, and 2 of them were 4 by 8, and you take 1/2 base times the width there. So you got 104 minus 10 minus 16 minus 10 minus 16. And these two subtract, you get 26. You get 26 here. So 104 minus 52, and you get a 52 for the area. And the same thing with 6. Use Pythagoras to find. Well, I didn't find these lengths because I didn't find the perimeter here. So the only thing I did was find these lengths on the outside here. And then the area of this triangle is 5. So 2 times 5 divided by 2 is 5. And then 1 times 11 divided by 2 is 5.5. And then this side right here, it's kind of covered up. This side is 9. Oh, let me get that. You get the 9 here. Figures. Undo that. There we go. So this side is 9. And this side is 11. So 9 times 11 is 99. And then I subtracted the 3 triangles there. And 99 minus 37.5 is 61.5. So that's one video on perimeter area. I'm going to make a second one and post it under the supplemental materials and videos. Also, put a paper copy of each of the pages I just went over. In the supplementary area.